Okay, so here are the notes and a harder example about proving quadrilaterals. The notes are these ones, and if you're using this to write your notes down, then you might like to pause the video here. But what they say is that when you're making a proof about a quadrilateral, the first step is to draw the quadrilateral. Then you label the properties that define the quadrilateral. So you remember in the previous example, I labelled the corners and I showed that I meant the sides to be the same length. You divide the quadrilateral up into triangles, so you might need to draw a diagonal in. And then you use congruent triangles to prove the conjecture. So pause the video here, write down the notes if you need to. Otherwise, just stick with me and I'll do a more difficult example. What I want to do is to prove that if the diagonals of a quadrilateral bisect at right angles, then it's a rhombus. So if you've got two diagonals and they cross each other at right angles, then the shape that joins up the corners of the diagonals must be a rhombus. Now, I'm going to need to draw a diagram for this, but you know that my diagrams are the worst in the world, so I'm going to use a piece of drawing software to do that. I'm going to start by putting a point on the page, and I'm going to say the point at which my diagonals meet, that they bisect. I'm going to put a dot there, and I'm not going to have a label. So there we go. There's my point. I'm going to put in lines that I know bisect at right angles at that point. They're going to be dotted lines. So here we go. There's my first diagonal. It's a dotted line, and the middle of it is right in the middle of the line, right where that point was. So I'm thinking that there's going to be a quadrilateral off this. It's going to come round like that somehow. And then we're going to look at that and see if we can prove that that somehow is a rhombus. Okay, so here's my second diagonal. It has to be at right angles, so I've got to draw it out like this. And it has to bisect, so I've got to do it like this. But they don't have to be the same length. The question doesn't say that, so I've drawn another line that's shorter than the first one, because I want to know that my answer looks reasonable and that I'm not just sort of taking a stab in the dark. So they're my diagonals. I know that they bisect at right angles. All I need to do now is, no, don't do that. All I need to do now is to fill in the corners. So I'm going to change to the proper line tool. I'm going to draw in the edges of my shape. That's 1, that's 2, that's 3, that's 4, and my conjecture is that that shape must be a rhombus. Now, are you thinking, do you know what a rhombus is? Because that's quite important. If we're going to make a proof about it, we need to say for sure what it is. The point about a rhombus is that it's a square that's been pushed over a bit, that's lying on its side. So a square has all sides the same. So that's what I need to know about this one. Is that shape a rhombus? Well, okay, let's copy it using another piece of software. I'm going to put it on my presentation and we'll work on it in the presentation. Okay. So, there's the shape that I drew. I'm wondering, is that a rhombus? So, what I'm trying to figure out is, can I put lines on each of those edges to make sure that they're the same? Well, I don't know whether I can yet, because I haven't proved it. What I do know for an absolute certainty, because I drew it that way, is that these lines are the same. Okay? This dot divides that diagonal in halves, and this dot divides that diagonal in halves, and that those angles in there are all right angles. I know that because I drew it that way. What I don't know is whether the edges are the same. If the edges are the same, then it's a rhombus, and we're done. So can you think, how would you prove that the edges of that shape are all the same? There's heaps of triangles there. Can you use congruent triangles to show that those edges are all the same. Well, look at, let's call the centre O for origin. Look at the triangle AOB and the triangle COB. Are those triangles necessarily the same? You've got the right angle in the middle. You know that this side is equal to that side. This side from O to A is equal to O to C. And that O to B is common. So those two triangles should be, using an angled side angle proof, we should be able to prove that triangle AOB is congruent with triangle COB. And if that's the case, those sides must be the same. And if they're the same, maybe we can do the sides for the other one. So let's go for it. Let's do the proof. In triangle AOB and triangle COB, first thing to notice, we're doing a side angle side proof. First thing to notice is that OC is equal to OA. And how do we know? We know because the diagonals bisect. It says it. It's actually given. The second thing, we want a side angle side proof. We know that COB is equal to AOB. Why do we know they're equal? Because they're at right angles. They bisect at right angles. So I'm going to say that angle AOB is equal to angle COB. And I know that they're both 90 degrees because it's given in the question. Side angle side. Side BO is common. So what we can then say is that therefore triangle AOB is congruent with triangle COB. And that means that AB is equal to CB. I need to give reasons here. That was an SAS proof. And how do we know that these guys are the same? Because corresponding sides in congruent triangles are equal. In congruent Okay, so I can actually put lines there that show that those are the same size, same length. Now, how would I say that this side is the same as that side? Because if I could put my 3 dashes on that, and I'd be nearly done. Well, I'd be proving that this side and that side are the same, this side is common, and that angle is right angles in both of those triangles. And so those are congruent triangles, and that is a similar side. So what do I say? Well, I could do the whole proof again, but we have a little cheat that we do, which helps when you're a mathematician and you have to do all this stuff over and over again. I just say, similarly. Similarly, triangle COB is congruent with triangle COD. Okay? And I'm just relying on the person reading the proof to be sensible enough to know that they can do an SAS proof on those two triangles. Therefore, CD is equal to CB because corresponding sides in congruent triangles are equal. So I can do that, and I'm just going to do that one more time. I'm going to use that similarly trick to prove that these two triangles are equal, ADO and CBO. I'm just going to say similarly, using a side angle side proof is what I mean. Triangle ADO is congruent with triangle CBO. And therefore, AD is equal to CB because corresponding sides in congruent triangles are equal. So I do this, and therefore I've proven that the shape that I drew, ABCD, is a rhombus. So there you go. You've gone from being able to prove things about triangles to now you can prove things about